Hey everyone, Mr. Newman here, and today we're going to learn how to use our arithmetic sequences when modeling problems. So first of all, you can model real-world situations and solve problems using these arithmetic sequences in this example. Suppose watermelons cost $6.50 each at a local market. The total cost in dollars in watermelons can be found using this formula. The first thing they want us to do is fill out this table. Well, we're going to have to use that formula right there. C of n equals 6.5 times n. So if we have one watermelon, that's C of 1. I plug in 1 where n is, so it's 6.5 times 1, that's 6.5. So I'm going to fill that out in that first spot on the table there. C of 2. Oh, also notice it says $6.50 each. So if you have one watermelon, each one costs $6.50. You only have $6.50 as the cost of one of them. We can use the formula for each of these, or we can reason it out and just multiply by each one. I'm going to continue with the formula. 6.5 times 2 is 13, so I know that 2 watermelons cost $13. C of 3, I'm going to plug in 3 there, and I get 19.50. So I'm going to type in 19.5 or write down 19.5 there. And lastly, C of 4 is 26. Now, what is the common difference? Well, remember, common difference is just that word for how much the sequence changes by each time. So to do that, I'm going to draw my little arrow and go, all right, how much did that go up or down by? It went up by 6.5, 650. Each one went up by 650, so the common difference is positive 6.5. What does n represent in this context? Well, let's see. We've got n watermelons, and watermelon stands for n, and it even says copy the table values for 1, 2, and 3, and 4 watermelons. So I know those 1, 2, and 3, 4 stand for watermelons. So n represents the number of watermelons. What are the dependent and independent variables in this context? Well, you need to remember that independent is x and dependent is y. If you forget that, a way to remember that is independent is input and dependent is output. And you should remember that x is input and y is output. So if we look at the table, input is usually on top. There's the output. Notice on our formula C of n, the n is in the input spot. So that's another way of knowing that n is the input. All right, so the independent variable is the number of watermelons because it's the input. And the output is a dependent variable. That's the total cost. Find C of 7, and what does this value represent? Well, C of 7, one last way you can see it. It said the total cost in dollars in watermelons can be found using this formula. The formula gives us the output, so total cost must be the output. That's the dependent value. All right, C of 7, we're going to plug in 7 into this formula they gave us. 6.5 times 7 equals 45.5. That means, what does it represent? $45.50 represents the cost of 7 watermelons. Notice, I basically rewrote this sentence up here, but instead of using n and C of n, I used the actual numbers. And you can often do that. I'll show you an even closer example the next time around. You could also say C of 7 represents the cost of 7 watermelons. Would be another way of saying that. All right. This table shows the distance in miles from the store after Mila has traveled for n hours. Determine the value of f of 10 and tell what it represents in this situation. I'm looking at that 10 there and going, that's a pretty big number compared to where we are in the table. So instead of finding out and just adding over and over and over and over, what I'm going to do is I'm going to figure out the formula and use it in this situation. So we have to remember, how do we get an explicit formula? That's the one that lets us calculate really big numbers really fast. Well, here is our generic form. F of n equals f of 1 plus d times n minus 1. And what you need to do is you need to remember what f of 1 and d mean, because we practiced that before. First of all, f of 1 represents the very first value in the first step when n equals 1. What is the output when n equals 1? Go ahead and take a moment to figure that out. And did you find it yet? Great. If you got 20, you are correct. F of 1 equals 20. Next, you need to find you need to figure out what the common difference is. Have you figured that out? That value is D. If you got 12, very good. It goes up by 12 each time, and that will be our D value. Then we just write down n minus 1. So this is our formula for the nth step. Let's plug it in for 10. So f of 10 equals 20 plus 12 times parentheses n minus 1. But instead of n, I plugged in 10. So we get 10 minus 1. 10 minus 1 is 9. 12 times 9 is 108. And 20 plus 108 is 128. What does this mean? Well, what does f of 10 mean? 10 mean that means when the input is 10, what the output is another value. But I want to read this sentence up here, and I'm going to say, hey, the table shows the distance in miles from the store after Milo has traveled for n hours. I'm going to rewrite that, but instead of using n and f of n, I'm going to plug in the numbers. 128 is the distance in miles Milo has traveled for 10 hours. Notice 10 is where n was, and 128 is where f of n was. All right, I want you to try this last one on your own. Once you're done, you can hit play and you can see what the answers are. Hopefully that's the formula you got. And then I've replaced the n's with f of 18. We solve it. And that is the f of 18. Lastly, what does it represent? 18 battery packs costs $72.90. Thank you very much for watching.